Say again?
Can you make that u plus 1 over 3?
U plus 1 over 3? That is what it is. So u plus 1 over 3, right? Since this is really 3/3 in disguise. So adding that to that makes that a positive 1 up there. And not only that, but now you have the 1/3 as a factor there, you can move to the outside. So write one more step though, just in case here. That times the root u to u, and now that's 1/9 u plus 1 root u du is the same as 1/9 integral u to the first times u to the 1/2. 1/2 is 3/2. So plus u to the 1/2 du. Use power rule reverse. 1/9. This goes up by 1 to 5/2, so 2/5 multiplied by the reciprocal of new power, halves, plus new power is 3/2, so 2/3 u to 3/2 plus c. Replace u with whatever we started with. 3x plus 2. Definite integrals. Same basic tactic, you have a computation at the end. 42. Is that what I said? Integral 0 to pi on 4 of sine on cos squared. We had something similar to this earlier. I hope it's more obvious now what to do. Substitution. What are you going to substitute? U equals, sounds reasonable. U equals cost. U is cost, and du has something to do with sine. And I see a sign up there. Okay? So if u is cost, which is the only, again, the only composition you see is cost inside a squaring function.
It's not squared.
Not what?
It's not cos squared.
It is cos squared.
It's cos cubed.
Oh, you're saying
Cos
for,
cubed.
oh, what is it? Oh, fine, cubed. So the only substitution, the only composition you see is cost inside the cubic function. So that's a good guess. And then once you differentiate it, du equals negative sine x dx. But I have exactly a sine x dx in the numerator, so that's a good deal. All right? The problem is the negative, so we'll exchange. I'll put the negative in the du instead. Negative du equals the sine x dx we have in our integrand. So it should then read.
Can you put the negative together?
Yes, that's exactly what I'm going to do, just like a constant, right? Usually it's just negative 1. So we're going to have negative 1 integral, instead of sine x dx, I'll just have a single du. And instead of the cost on the bottom, we have a u. So it reads 1 over u cubed du. All right, so here comes the new thing on this one. That was old news. Okay, everybody's okay with that so far, right? No big deal. So what are the limits of integration?
So this is to the negative.
Say again?
This is u to the negative.
I cannot hear you.
Would this be u to the negative 3?
It is, that's true. We're going to rewrite this as u to the negative 3 in a second and do a reverse power rule on it. But right now, I need to figure out what to write there. This is a definite integral. Right now, I have it posed as an indefinite integral, but I don't put any limits to the integration on there. So what do I put there? I can't put 0 and pi on 4.
You flip it.
Put pi on 4 and 0?
Yeah.
Oh, no, that's not because of that. That negative is not something I superimposed in the problem. That came from the relationship between du and dx. So it's not that scenario, really. Okay? Now, remember that this is saying what x is going from and to, right? On the x-axis, you're going from 0 to pi on 4. So now you're changing it to some sort of u-axis in some other plane, right? So what is u going from and to?
0 to x.
1 to square root 2.
So Serrati says from 1 to square root of 2 on 2. Anybody disagree with him? Serrati's been on the money most of the time. You may not want to argue with him.
Can you explain
So you just put like those values in and those on.
Yeah, exactly. I've got to know what u is now, right? When it's x, I know it's 0 to pi on 4, the problem gave me that. But now that I've changed the whole thing to an antiderivative with u, so what is u? U is cos x. So if you put 0 in here, what do you get? You do lower limit of integration. If you put pi on 4 in here, what do you get? Root 2 on 2, your new limit of integration.
So you have to substitute.
You must run the limits of integration through the transformation you chose.
You have to
Is
put
that what you're gonna say?
You have to put it into the u.
No, you have to put you have to put it into the x, so you know what u is.
Wait, so you plugged in the
Limits of integration into your transformation.
Yeah.
to
That's
get
right.
the, to get the pi over those two things.
That's right.
Okay.
That's what you gotta do.
So when you plug u back into the equation, do you keep those two now?
When I plug cos x back in,
Yeah.
I don't have to plug cos x back in now. That's what we're alleviating.
Oh, so you
I do
don't-
not have to make the resubstitution at the end now. I'm just gonna plug the numbers in directly.
Oh, okay.
That is what is saved by doing that little process there and getting new limits of integration. Okay? Say again?
No.
Okay. So now, Raja, let's do what you said though. Just so you guys get some practice with that idea. What does this negative imply? It means I could use it up and switch these two, right? That's what it implies. Switch limits of integration and take the negative out of there. So we could rewrite this as root 2 on 2 to 1 u to the negative 3 du. Just we don't have to mess with that negative at all in the next step of the problem. That's one way to deal with it. If you don't want to do that, it's your choice. I really don't care. But just so you remember that you can at least do that when you want to. Maybe other scenarios where you actually want to do that. So u to the negative 3, bump that power out by 1, so goes u to the negative 2. And divide by the new power of negative 2. So negative 1/2 u to the negative 2, evaluated from root 2 on 2 to 1. Right? Fundamental theorem time. I bump the power up to negative 2. I'm going to divide by the new power. So equals, I'll leave the negative 1/2 on the outside of the whole thing. And now on the inside, I'll have root 2 on 2, sorry, 1 to the negative 2 power, this is word notation or whatever, minus root 2 on 2 to the negative 2 power. Agreed? What's 1 to the negative 2? Don't hesitate. What's 1 to any power? All right.
I was thinking in dramatic pause.
You're driving, okay, thank you. Yeah. Drum roll, it's 1. Somebody's going to ask somebody who's going to be on the street. I'll give him a Dodge to know what 1 to any power is. Sorry, I can't give him mine now. So we have 1 minus, what does a negative exponent imply? Reciprocal, right? So, what is it? Right, the whole thing's 2. So we take the reciprocal, what's 2 over root 2? Root 2. What's root 2 squared? 2, right? So the reciprocal changes this inside into a 2.